Alright, let's get back into section 5.3. This time we're going to look at the power reducing formulas and then the half angle formulas. The power reducing formulas are just as the name kind of indicates. It takes powers of trig functions, in this case sine squared, cosine squared, and tangent squared, and reduces them down to trig functions that are to the first power. Now the first two here, as you can see, are very similar. One's got subtraction, one's got addition. And of course, tangent, sine divided by cosine, so tangent squared is sine squared divided by cosine squared, this over this, which reduces to this. Now, I'll use these two quite a bit in Calc 2 when I'm doing techniques that involve powers of trig functions. And we're going to do an example where we're going to write cosine to the fourth power of x in terms of first powers of cosine. Now, cosine to the fourth power of x is equal to cosine squared x times cosine squared x, which is, now the cosine squared of x would be 1 plus cosine 2x divided by 2 times itself, 1 plus cosine 2x divided by 2. And then if I multiply on top, I get 1 plus 2 cosine 2x plus cosine squared 2x, and that's all over 4. Now, the reason I'm doing that is because I have to make one more substitution, because I am hoping that you will see I haven't quite accomplished my goal. I don't have it all in first powers of cosine. I have a cosine squared. So I went ahead and divided through by 4 and rewrote these with fractions. This guy is okay. This guy's to the first power, he's okay, but this guy, I need to make that same substitution. But notice though, now it's 2x here for my theta. So I am going to get 1/4 plus 1/2 the cosine of 2x plus, this is going to be 1/4 times, right here, 1 plus cosine of double the angle, so that would be 4x all over 2. Now I'm going to go ahead and do a little work here. I'm running out of space. I thought I could get this all in here. This is the same as 1/2, so I'm going to write plus 1/8 plus 1/8 cosine of 4x. I went ahead and broke this by dividing 2 into both terms and distributing through by 1/4. Now I can simplify this a little bit because I do have like terms. 1/4 plus 1/8 is 3/8. So I'm going to fit it here. I'll put it right here if I can squeeze it in. All the way up here I'm going to write 3/8 plus 1/2 cosine 2x plus 1/8 cosine 4x. Not a very good way to finish writing it out. I hope that you can read that. Maybe I better take the time and write that again. I'll put it right up here so you can see it a little bit easier. 3/8 plus 1/2 cosine 2x plus 1/8 cosine 4x. That's what this guy is equal to right up here. There we go. Now, we won't do a ton with this in pre-calculus, but we will use this in Calc 2. I guarantee you. So it's not going away, especially these two guys. The half angle formulas, as it turns out, we get these two guys from the half angle formulas. If we were to square both sides, you can kind of see it coming with those expressions. But we have the sine of an angle divided by 2 is plus or minus, and of course that kind of depends on the quadrant you're in. The square root of 1 minus the cosine of the angle divided by 2. That 2 is under the radical. That's under the radical. I don't want you to think it's in the bottom there. And then very similar, notice just a change in the SIGN sign there. The cosine of alpha over 2 is plus or minus, again based on the quadrant, the square root of 1 plus cosine of alpha divided by 2. And the tangent of alpha over 2, if you divide this by this, which is sine over cosine, right? You get this simplified, but even better are these two guys right here. Both of those guys, in fact I think in the book, they may have even derived how they go from here to one of these two forms. It's several steps, I'm not going to go through it now. I don't think it would help a whole lot being able to derive it, but you should memorize it. I like to use this one because of the plus sign. Just one less thing to worry about is to have to deal with a subtraction, maybe subtracting a negative or something. Now I'm going to use the half angle formula, and it says you have to use the half angle formula So you can't like do the sum formula like 120 plus 45. Use the half angle formula to find the exact value of the sine of 165. So would you agree that the sine of 165 degrees is equal to the sine of 330 degrees divided by 2? That's 165 divided by 2. I'm putting it in this form so that I can use this formula. Now wait a minute, the sine of 165, is that positive or is that negative? It's positive. So you see up here where it says plus or minus, I'm just going to use the plus. So this is my alpha here, this is my alpha, and it's going to go right there in the formula. So I'm going to get the square root of 1 minus the cosine of alpha, 330, and that's all over 2. Well, the cosine of 330 degrees is, let's see, cosine of 330 would be, cosine would be positive square root of 3 over 2. So this would be the square root of 3 over 2, and that's all divided by 2. I could multiply top and bottom by 2. Here, I'll bring it back over here. And I would get the square root of 2 minus the square root of 3 all over 4, which is the square root of 2 minus the square root of 3 all over the square root of 4, or 2. And that's how I would leave my answer, even though there's a radical inside the radical. That's your exact value. Jump over to here. We have all three of the half angles here, and we are given just a little bit of information. We know that alpha is in the fourth quadrant because it's between 3 pi over 2 and 2 pi, fourth quadrant. And we know that the sine is negative 5/13, which makes sense because in the fourth quadrant sine is negative. Now, because sine is negative, it's a fourth quadrant angle, I'm not going to set up a right triangle with alpha. I'm going to set up a right triangle with what I call alpha prime, which would be its reference angle. And if the sine of alpha is negative 5/13, that would mean that the sine of alpha prime would be positive 5/13. And Pythagorean theorem, we'll notice that it's a special right triangle. It's a 5, 12, 13 Pythagorean triple there. And then that tells me that, what will I need? I will need cosine. That would tell me that the cosine of alpha prime would be 12/13. And that also means, since cosine is positive in the fourth quadrant, it's also 12/13. So let's see what information I need now. The sine of alpha over 2, going right to this formula, I pointed to the wrong one there a second ago. This is sine. Sine is negative in the fourth quadrant. Let's see, hang on a second. No, hang on a second. This is in the fourth quadrant, so that means it's between 270 and 360. So if I divide it by 2, it's between 135 and 180. So that's actually in the second quadrant, and sine is positive in the second quadrant. Okay, second quadrant, better write that down. Alright, so the sine of alpha over 2 would be positive the square root of 1 minus the cosine of alpha, which is 12/13, divided by 2. So this is 13/13 minus 12/13. This would be the square root of 1/13 divided by 2, which would be the square root of 126, which is 1 over the square root of 26, which is the square root of 26 over 26. And there's the first value right there. Now, next guy up is the cosine. Now, in the second quadrant, cosine is negative. So this is a second quadrant angle because we determined that from here. So the cosine of alpha over 2 would be negative the square root of 1 plus 12/13 all over 2. So that's 25/13. 25/13, the opposite of 25/13 divided by 2 is 25/36, or 26, which would be negative 5 over the square root of 26. So I multiply top and bottom by the square root of 26. Oop, 26, not 62. And I get negative 5 square roots of 26 all over 26. Well, we're getting there. Tangent in the second quadrant is also negative. Now, I can use any of these I'm going to use this guy right here. I just think he's easier to work with. I need the sine of my angle and the cosine of my angle. I have them over here. Remember, the sine was given, and there's the cosine. So this is equal to, now notice, there's no plus or minus. I don't have to worry if it turns out to be positive or negative, because I know it's going to be exactly what it's supposed to be. I'm telling you right now, this is going to be negative, because tangent's negative in the second quadrant. So it's not, you don't have to use this one, and you'd have to determine that it would be negative. You're going to just use either one of these two, and I'm using the bottom one. So I have the sine of alpha. Here, we're going to go ahead and write it all out first. All over 1 plus the cosine of alpha, which would be negative 5/13 all over 1 plus 12/13. Well, you can see it's negative in the numerator, positive in the denominator. Negative 5/13 all over, this is 13/13, so this is 25/13. This is negative 5/13 times the reciprocal 13 over 25. Oh, that's kind of nice. This goes all the way down to negative 1/5. And that would be the value for the tangent of alpha over 2. So there are all sorts of different kinds of problems that you can do with the double angle, the half angle, and the power reducing formulas. And of course the key is to always practice, practice, practice.